In the previous content, we have learned about the fixed points of the bilinear transformation. And now we are going to start the normal form of the bilinear transformation. And the theorem states that every bilinear transformation with two finite fixed points, alpha, beta, can be put in the form w minus alpha over w minus beta is equal to lambda times z minus alpha over z minus beta. So this is for the two fixed points alpha and beta. So now let's start the proof. Consider any bilinear transformation and let fixed points of that bilinear transformation is equal to alpha and beta, that is given to us. Okay, let me consider one more point in the z plane, that is, let's say gamma, and it is transformed to delta in the w plane, right? So now I am having 4 points in z plane, two fixed points alpha, beta, and this gamma and z point, right? And in the w plane, the transform points are alpha, beta as it is because these are the fixed points, and then I'm having delta in the w plane and w itself, right? So alpha, beta, gamma, z. This is mapped into alpha, beta, this gamma is transformed to delta, and z is into w. So these are the points in z plane, and alpha, beta, delta, w, these are the points in the w plane. So now I can use the cross ratio preservance. So by cross ratio preservance, the cross ratio of the points in the z plane is equal to cross ratio of the points in the w plane. So according to this, yes, what is the order? W minus alpha over alpha minus delta into delta minus beta over beta minus w, right? Similarly, here also z minus alpha over alpha minus gamma into gamma minus beta over beta minus z. Now because I need the form as w minus alpha over w minus beta, I need this to be in the left hand side, right? So here I'm having w minus alpha, right? And I need w minus beta. So just taking this sign common, so I get w minus alpha over w minus beta, and this negative sign will be managed by this delta minus beta can be written as beta minus delta over alpha minus delta. Similarly, here also in the right hand side I need z minus alpha over z minus beta. So just managing the signs, z minus alpha is as it is over this is beta minus z, so I can write it as z minus beta, and the negative sign is managed by this gamma minus beta, that is beta minus gamma over alpha minus gamma. Fine? Okay. Now taking this factor to the other side, because I need only w minus alpha over w minus beta in the left hand side. So which is of the form w minus alpha over w minus beta is equal to alpha minus delta over beta minus delta and beta minus gamma over alpha minus gamma. Beta minus gamma over alpha minus gamma with z minus alpha over z minus beta. Let me take this as lambda. So finally we get the normal form of bilinear transformation as w minus alpha over w minus beta is equal to lambda z minus alpha over z minus beta, where this lambda is equal to alpha minus delta over beta minus delta into beta minus gamma over alpha minus gamma. Let's move on to this remark. For finite fixed points, considering the bilinear transformation as w equal to az plus b over cz plus d, and let fixed points be alpha and beta. To get the fixed points, we put w equal to z. So putting w equal to z, we get z equal to az plus b over cz plus d. And when I take this denominator to the other side, which gets multiplied with z, I get a quadratic equation in z. So this implies cz square plus d minus a z minus b is equal to 0. And because alpha, beta are the fixed points, so the roots of these equations are alpha and beta. So the roots of the equations are, yes, taking alpha is equal to first root to be as alpha, that is d minus a plus square root of the discriminant, that is d minus a whole square plus 4bc divided by 2c. Mark this as 1. And then beta is d minus a with negative sign and the square root of d minus a whole square plus 4bc divided by 2c. So these are the two roots as the fixed points, right? By the theorem, the transformation can be put in the form, yes. If I am having two fixed points alpha, beta for the bilinear transformation, then that transformation in normal form can be put as, yes, w minus alpha over w minus beta is equal to lambda times z minus alpha over z minus beta. Please mark this as 3. Now to determine this lambda, right? To determine this lambda, I'm having the bilinear transformation as w equal to az plus b over cz plus d. If you observe over here, if I take the denominator to be equal to 0, then this w will be infinity. So if this denominator is 0, that means cz plus d is equal to 0, that is z is equal to negative d over c, implies that the point z equal to negative d over c transformed to the w equal to infinity. From here, just put the value of z as negative d over c and w as infinity. Then we can get the value of lambda. So putting w equal to infinity, that is infinity minus alpha over infinity minus beta is equal to lambda z minus alpha, that is minus d over c minus alpha over minus d over c minus beta. So from here we get, just taking this infinity common, I get 1 minus alpha over infinity, and alpha over infinity is 0. So here I get 1 in the left hand side. So this is equal to lambda. So this is d plus c alpha over d plus c beta. That implies that lambda is equal to d plus c beta over d plus c alpha, which is the required lambda for the two finite fixed points, right? Thank you so much.